Hi, welcome to Teardown Tuesday. Yes, I think I'm officially a vault nut. What is a vault nut? Well, anyone who has an 8.5 digit multimeter, pretty much. I think that's probably the definition. And yes, I've got one. I foolishly went and bought an 8.5 digit multimeter. No, it's not the classic HP 3458A, of course, which is the world's best, but this one's not bad. It's an oldie, but maybe a goodie. We'll find out. Anyway, it's from a company you've probably never heard of. They're called Prema. And they're still around, but they're like a semiconductor company basically, and they specialize in semiconductors. They roll their own ADCs and things like that, and DC voltage standards. And well, back in the day, in this case the late 80s, they designed and sold an 8.5 digit multimeter. So I got this on eBay, and well, I don't know, I just got it from the post office, and I'm a bit horrified by the lack of packaging. You can just tell by the physical size of this, because these are large multimeters, so there can't be much in the way of packaging in this thing. And the person at the post office went out the back and got it, brought it back and sort of tossed it down on the counter. It sort of went thud, and inside I just went and well, yeah, I don't know if it's made it intact. That's one of the things with buying test gear on eBay. Not only do you not know if it works or not, and is still within spec, this one I think was sold as, it powered up, but it was, it hadn't been touched. It had been in storage in a case or something since it was last calibrated or something like that. So, a reasonable level of confidence that it's going to work, I think, but certainly not guaranteed. And obviously they clearly don't know how to package test gear properly, because I don't think there's much in the way. We've got a box in here, and anyway, yes, the thing is, you don't really know on eBay what you're going to get or how they're going to package the things. Even if it is good, when it gets shipped around the world like this, who knows? Just tossed on the counter at the local Australia post office. But hey, what happened on the 747 flying here, and the cargo hold and the baggage handlers and everything else? Well, and not baggage handlers, the commercial handlers, I guess. But gee, I don't know. Only one way to find out. Let's take it apart. Unfortunately, I'm not going to have to do the don't turn it on, take it apart thing. I'm going to have to plug it in straight away and see if it still works, I think. But after that, we'll tear it down. Let's go. All right, here we go. There's bubble wrap in there. There's going to be like one layer of bubble wrap, or maybe two at most. But usually when I get test gear like this, and if it comes from a good reputable test gear reseller, for example, they will know how to package it, and they'll vacuum pack it in the custom foam or something like that, or at least heavily pack it in foam peanuts and things like that. But this is really quite hodgepodge. And yeah, look, there's one or two layers of thin bubble wrap, and of course the look, nothing on the corners here. Look, nothing on the corners. So the problem with that, when you ship things like that, all of the shock gets taken on there. So when this thing gets thrown around, bang, you're really going to get the shock transferred into here. And then of course, that being all originally mounted inside, that's going to transfer through to the PCB inside. And curiously, it's got a bit of cardboard in there as well. So there we go. They've at least done the right thing, and at the very least they've put a cardboard covering on the front panel, so that's not too bad. Okay, I'll give them props for that. They've at least thought of that, but they haven't thought of transferring that shock through to the chassis. But it doesn't look physically damaged, so it looks like it's made it in one piece. Woohoo! Will it work? I don't know. So yeah, it's in reasonable nick. I don't mind it at all. Looks like the cowl seals might be broken on the thing, but yeah, really old school look of it. Look at this old school 7-segment red LED display and the old illuminated push buttons. Really old style banana jacks on these things. I mean, check that out. That is just old. That's really old school shrouded banana plugs and a couple of more 7-digit displays, but 7-segment displays. But well, let's power it up. This is, by the way, the 6047. There also is a slightly higher spec 6048, but this is 8.5 digits, 1 ppm stability or thereabouts, is short-term stability. I think the 6048 is 0.5 ppm stability. I will link in the manual for this thing down below, but I did get a full manual with it, so that's pretty good. Got the original printed manual. Oh, look, schematics. Schematics. Awesome. We got the full schematics. I haven't checked online if the online schematics have, if the online manuals have the schematics, but look, there's the whole front end. And there is the ADC. There it is. Look, they rolled their own custom Prema ADC in this thing. So, yeah. There you go. I think this uses either the LM399 voltage reference or the LTZ1000. I think the higher end one might use the LTC Z1000. But anyway, let's power the thing up and see if it works. And yeah, that cowl seal looks slightly broken. Ah, well. And on the back, there's not much. It looks like I don't have the multi-channel option on the thing, but there you go. I've got serial number 1041. They didn't make many of these. I'm not sure of the exact age. There's no date code, but we'll find out from the chips inside. And it's got a GPIB and an external trigger using a 3.5mm jack and standard 2-foot. Well, I don't know if it's universal. No, there's the voltage on there. I have to switch that around, so better make sure I get that right, otherwise I don't want to blow the arse out of it. Alright, here we go. Have I bought a dud? Controller 1, whatever that is, but that's promising. It means the processor's working and it's booting up. Controller 4, whatever. Hey, there we go. We're in like Flynn. It's in milliamp mode, but volts DC, there we go. 200 millivolts. There we go. Let's switch to 2-volt mode. Obviously, it's got high input impedance because it's counting up. So, there you go. Excellent. 200 volt range. There you go. Once you get to 200 volt range, it's not high input impedance anymore. So that's why it's quite low. But you switch it down to 20 and yep, it's got that high input impedance. Now just a very quick check with my little resistance box here, 10k, it's around about that, you know, down to the 4th digit there, pretty much. Let's whack it in here and see what we get. 20k, yeah, there we go. Hey, winner winner, chicken dinner. It's interesting that on the resistance range here, if it goes over range, it actually tells you error 1. I was a bit mortified when I first switched on the resistance range. Ooh, error. And here we go. I've hooked it up to my 10-volt EDC lab standard here, but I just plugged it in like a minute ago. So really nothing's warmed up, and the Prema 2 has only been on for, you know, 5 minutes or whatever I've been filming. So yeah, we're a little bit out, but our Agilent is much closer there, 99996, whereas down here, yeah, it's a bit out. So whether or not it just hasn't warmed up yet, I have no idea. I have to leave it going. I haven't, you know, to do proper performance tests on this could take days or something. It's not easy, but it basically works. So, you know, whether or not it's within spec, because we're talking the Agilent 344618 6.5 digit multimeter, typically in the order of 0.005% accuracy in terms of like a 1 year accuracy. This Prema, 8.5 digits, 2 full digits more, pretty much, although this is 10,000 count. Anyway, this is 8.5 digits, goes up to 20, so it's 19999. And it's in the order of 0.0005%. So an order of magnitude 10 times better basic DC volt accuracy spec than a 6.5 digit, top of the range 6.5 digit meter like the Agilent 34461A. So that's the sort of, you know, even though you're jumping up 2 digits, you're only jumping up 1 order of accuracy pretty much. Yeah, and basically the same on the 1 volt range as well. Look, the Agilent's pretty darn close to spot on, and I've done previous videos on this. This thing, I've taken it to the local cow lab. I'll actually link in that down below, and this thing is bang on when you let it warm up. But yeah, look at that, 0.99999, so we've got 5 nines there. We go over to here, and we're on the 2 volt range, 99998. So yeah, something's out. I don't know. As I said, got to let it warm up, do some more tests, but not that great on the DC volts. I was expecting more. I don't actually know how to switch in the extra couple of digits here. Don't know how to work this thing yet. You know, it's got all sorts of measurement modes, and you can set the integration time and all sorts of stuff. That would do it. By changing the integration time, you'd likely get your increased resolution there. And if you're curious to know how much power it takes, there we go. I've got it hooked up to my power meter here, and it's taking about 16 odd watts or thereabouts, or 18.5 VA. Woohoo! With a power factor of 0.863. Terrific. Well, it basically works, so there's only one thing left to do, and that's take it apart. Now, of course, what we expect in this sucker is pretty much, you know, late 80s vintage. So we're looking at all through-hole components or dip packages, stuff like that. I'd be surprised if there's any surface mount in here, because they wouldn't have optimized this for manufacture, that's for sure. This is only serial number 1000, so not exactly huge. Can I lift that up? Here we go. We're in. Oh, look at that. Beautiful. Check that out. 3 boards and... Oh, hang on. Oh yeah, vintage precision test equipment smell. Love it. Well, it looks like I was pretty bang on when I said they wouldn't have optimized this thing for production. They sure haven't. Look, this is sort of the construction you'd find in sort of, you know, that one-off or low volume test gear you might typically, or I've typically designed in the past for, like, you know, production testing and stuff like that. You know, you want to manufacture 10 of them. You know, this is probably what you'd end up looking like. Look, 3 separate boards just sort of, you know, tied into rails down on the bottom there. Looks like they've got a couple of rails through there, just a couple of standoffs, so nothing fancy in that respect. No fancy mounting or anything like that. By the way, there's no fan in this thing at all. Completely silent. As you saw, it only drew 15 odd watts or thereabouts. But anyway, transformer up here, right hand board construction soldered directly onto that. Then a little board, very nice looking board to board interconnect there. And looks like there's our main voltage reference there. A couple of huge relays in here, but really just double-sided board construction. We've got all our processing happening over here. Good old EEPROM in there. Don't want to lose that data out of that. You may not get that back in a hurry. Ooh, is that a real-time clock chip? One of those Dallas real-time clock chips under there, perhaps? But yeah, we've got some precision front-end stuff happening over here. We've got it under a shield, but yeah, nothing fancy whatsoever. So socketed, everything is basically socketed. Looks like we've got some precision foil resistors here. They look like Vichy ones, Z foil construction if they were around back in the late 80s, but that's what they look like to me. And yeah, it's just basic through-hole technology. Nothing fancy whatsoever, all off-the-shelf parts. This thing would be entirely repairable, especially when you've got the schematics. Even without it, geez, you could easily trace this circuit out and figure what it's doing. Unless, of course, the custom ADC, which is probably under here. I see a couple of custom chips with weird-ass part numbers. They're most likely Prema custom chips, because they are a silicon company, and I know for a fact they rolled their own analog to digital converter inside this thing. And it's all a bit how you're doing too. I mean, we've got this single in line thing. I have to look at the other side, but it's just bent over at an angle there. Look at these precision resistors here. There we go. Like they're only 1%, of course. They're not high tolerance, but they would be, you know, practically zero tempco, zero drift in these things, because, you know, they're probably paid a couple of $100 each for those resistors to get them. They probably got the best Vishay had to offer at the time, and yeah, nothing but the best would have gone into these things, because the drift in this unit, as I said, even in this unit is 1 ppm. So that's its nominal drift spec or something like that. And the higher end one is half that at 0.5 ppm or something like that. And look, then they've got this metal can package just bodged into this dip socket up here. And it is all very handmade. It's not like this is you know, any sort of, you know, high volume production at all. Probably each one of these was individually handmade to order, most likely. And I think that is the widest clearance I've ever seen on any standoff bolt at all. Look at that. They were really paranoid. Let's not go anywhere near those suckers. Could be guard traces on there. I see a couple of these are missing the solder mask, so that's what they could be doing there. Then you find weird stuff like this. There's a 74HCT 4046 there, and just a crusty single turn trim pot on the board. You think, you know, this doesn't look like a precision world class 8.5 digit DMM, that's for sure, but it is, because you know, that's not the important stuff. All the important stuff is happening under here and getting, you know, zero tempco pretty much, because once you've got, you know, there's, you know, you whack some high quality relays in there, some precision resistors, and then you get a precision hand selected, hand aged, no doubt, voltage reference in here, and you combine those things together, and with a precision ADC, which they've rolled their own in this thing. We might be able to find it eventually, and yeah, bingo, you can get 8.5 digit performance. Doesn't look like it. Just by looking at this thing, you wouldn't say that this is, you know, any sort of precision instrument at all. And bingo, date code, we're talking, you know, 41st week 88. That's probably like the oldest, or the newest, sorry, I can find in there. Some of them are quite old. Like, look at this over here. We're talking, you know, 85, 34th week 85. Geez. Although the, look at this, is that 91? I guess was the last ROM code on there. Ooh, look, that's coming off. Check out some of the soldering on this. Looks like somebody's had a hack at that from the top, almost as if they've replaced that diode in there. I don't like the look of that at all. And similar things, you know, happening up here. That's just not great. There's, like, they've been bodged on and hand soldered. Some of it looks, you know, like it's properly wave soldered, and then other things look like it's been bodged on. Maybe I've got one that's been repaired, perhaps. And that black single in-line package we saw before, look at that, 100 milliohm shunt resistor. Once again, it's only a 1%. The absolute accuracy in these things does not matter. It's all about the tempco. So, Ziranin, I don't know. I can't pronounce that. Isabel Shoot, I don't know. Can anyone name the manufacturer or get a data sheet for that sucker? Whew, never seen that before. And all throughout this thing, they're using German SDS relays, so top quality. And of course, in a precision 8.5 digit multimeter, the connections matter, like the physical material themselves. Once again, they will probably be tellurium copper contacts, really expensive, really high grade. You don't want any voltage differentials in there at all. And of course, here are our custom chips. Dead giveaway. They're marked PR, which is Prema, obviously, designed and manufactured, being a silicon company. And this one's got BK7. I don't know. You'd have to look up the manual and schematic for that one. And of course, as far as the power supply goes here, nothing fancy at all. They're running a couple of taps off here, all nicely heat shrunk, and they've got cardboard in here actually protecting that mains wiring stuff, so that's really pretty good. Then we've got a big bridge rectifier here. We've got a small PCB mounted, well, smallish for a TO3 package anyway. TO3... yeah, it's an LM309K, there you go. And then just a big 4700 mic filter cap. So, you know, your traditional linear supply just generating the 5 volts needed for all this stuff. And then, of course, they've got the board-to-board connector down in there. There it is. It's very quiet. It's quite nice, actually. I rather like the look of that one. And, yeah, just some small local linear regulation around here as well. Once again, you need those for the plus-minus rails. And of course, opto couplers for everything, as you'd expect. That connector's all just on an angle there. Really dodgy, thrown together. It's quite amazing. Yeah, here we go. These are all on an angle like that. Anyway, here's your opto couplers here. So between your digital processor board over here and just this, this could be part of the sampling logic. All your analog's going to happen over here. So you expect to find your ADC over there, but it could... no, actually... based on those kick-ass looking sampling caps in there, I'd say that's our analog to digital converter without having to look over here. So clearly they've got to get the signal over these ribbon cables here, but you know, it's going to be sort of full level type stuff. So that's probably our custom ADC, our integrator ADC down in there, and opto couplers out here as well. This is just to get some probably some digital data over to drive these relays. All this relay switching over here, it'd probably go via these opto couplers here, and then your data output serial, of course, because you haven't got enough lines there for parallel. So serial data out of your analog to digital converter straight into your processor board over here. Well, I took the shield off this thing, and look at this. We've got more bodginess. I mean, take a look at that. It looks like we've got some what looks like polystyrene caps, just like bodgily, what, you know, paralleled up there, and we've got a couple, you know, just afterthoughts just added across this resistor divider here, you know, probably to improve the AC performance of that thing. And well, it's pretty crap. Look, we've got ourselves some nice trimmers here. These are all available through the top of the can there. These little reed relays in there, I suspect they could certainly well be reed relays for switching in there, but yeah, geez, it's really just sort of thrown together hodgepodge, not professional at all. And no surprises for finding the classic AD637 true RMS converter IC. That's been used in every multimeter since day dot. And as I said before, voltage reference, classic LM299AH. There we go, and it's not that one of those rebranded ones. As I said, the upper model to this, the 6048, it's, I believe, got the LTZ 1000 voltage reference in there. So that one's slightly better than the LM299 used in this one. But as I said, that would have been hand selected, hand aged, all that sort of stuff. So only the best would have been placed into this thing. Probably individually serial numbered maybe. I don't know, I can't see anything. But yeah, they certainly would have been hand picked. Now, the thing I find very interesting about this is all of the sockets in here, even for all your precision parts, they're just crap sort of looking dual wipe contacts. Not even... it doesn't even look like they're gold plated at all. I don't like them. Made in West Germany, I presume. See, there's some of that horrible hacked on rubbish. Those polystyrene caps just soldered across there. Oh man, leaves a bad taste in your mouth. And if you're wondering what that puppy is down in there, bodged into the dip socket, it's an LM343 high voltage op amp. And you can see an example of the guard traces. This one is for the ohms range, so there you go. These ones are, that's the guard trace going all the way around there, as you've seen in previous videos, to stop leakage between critical nodes. Now, of course, all these trimmers you see in there, they wouldn't be set in the references. They're just trimmer caps in there designed to just tweak the AC performance of each range. Oh, look at that. Pair of thermally bonded transistors. They're in love. Wonderful to see. There we go, we got ourselves a hand serial numbered ceramic resistor divider or high voltage resistor network in there. So yeah, it would have been individually tested and characterized, no doubt. Coax! So, well, what can you say about this? I mean, I expected a bit more spit and polish for a 8.5 digit meter of this sort of performance. It really is quite kick-ass performance, especially for its day. Even today, it's a really top spec unit. Now, whether or not it's still within spec, I don't know, because as I said, there is a non-volatile RAM up here, and that could be keeping the calibration constants in it. I would have to read the manual and see how this, presumably it holds the calibration constants in software in there, and you could, during factory calibration or calibration adjustment of this thing, not just calibration check, but calibration adjustment, they would program in those calibration factors into there, so they could be lost. So that's maybe why it could be on very quick initial testing, potentially out by a little bit. But yeah, still, anyway, that is just it's just bodge central. It really is. It's like they just slap these together by hand. Not a huge amount thought given into the production side of things and the spit and polish. But hey, it goes to show that you can make an 8.5 digit, world-class performance DMM with, this sort of simple construction technique. If you know what you're doing, anyone can do it. But hey, there is a bit of secret sauce that goes into that custom ASIC analog to digital converter there, and that's where the manual has to step in, and you can read all about it. Oh no, I should have read the specs of this thing better. It looks like the 6047 that I've got is only a 7.5 digit resolution. It's not the 8.5 digit, which is the 6048. There you go. So I'm not officially a volt nut. Here I was thinking that I'd gotten an 8.5 digit meter, but I don't think I have. Bummer. Oh, they're really big on math. Look at this. These are all the functions built in. Ratio, power, polynomials, non-linear function. Got logarithms, square roots, tangents, arctangents, all sorts of fantastic stuff. Variance, standard deviation, all that sort of stuff built in. Terrific. And there you go. If you want to calibrate the thing, there's a calibration button on the switch on the back, which you've got to set first, and you enter program 99. Now I can see that that cow sticker is still in place on mine on the switch on the back panel. So presumably nobody's tried to fiddle with this thing. And for those who want to know the specs, here you go, the 6047. Look at that. This is 24-hour drift specs. Look, 0.0001 1 ppm or half a ppm there for the 6048. Killer accuracy, 90-day accuracy. Even at this one, see, the 6047 isn't a huge amount better than the 6048, for example. Look, it's, bugger it, like one digit in it there, 0.0004 instead of 0.0003. Not a huge difference there between the two. And as I said right at the start, the 1 year nominal accuracy, 0.007% there. So yeah, that is like an order of magnitude better than my Agilent 3446-1A 6.5 digit meter. And even the 1 year specs on the resistance here, pretty impressive. Goes down to as low as 0.0009% there for 1 year accuracy. And there you go, the ADC multiple ramp. They've got a patent on this thing, German patent anyway. You can go look that one up if you want. I mean, old hat these days, but back in the day would have been a big deal. And yeah, it's just an integrator. That's pretty much what it is. Now, as always, I'll link in down below to the EEVblog.com website for the high-res teardown photos of this thing, plus the schematics as well. And this is the 6048 schematic. So that's the higher end model, and that's the 6047. So check the difference. There we go. I can see we've got some extra circuitry up here as starters. What else have we got? Oh yeah, there's quite quite significant differences happening down around here. And this is the 6048. This is some of the additional circuitry, obviously, to power the better reference, the LTZ 1000, as you get. Same one you get in the classic HP 3458A. And once again, would have been individually hand selected. And if we flip over to the 80... the 47 that we've got here, where there we go, the LM399, even though what they got installed is an LM299, but basically the same thing. Oh, lovely relay sound, beautiful. Anyway, I hope you enjoyed that teardown of this rather unusual Prema 6047 integrating digital multimeter. Bit embarrassed. I thought it was 8.5 digit. This is when you're rushing to buy stuff just randomly, you know, you don't do your research properly. I thought it was an 8.5 digit meter, and I thought that the specs were the only difference between the two, but it's 7.5 digits. Anyway, I got to do some more work on this sucker and see if it is within spec. It just may need some warm-up time or something like that. Anyway, needs a fair bit more playing around, but yeah, rather unusual beast from the late 80s. Hope you enjoyed it, and as always, if you want to discuss it, EEVblog forum is the place to do it. Catch you next time.